Hey everybody. We are on our last video of this entire unit, which is on laws of exponents. So, just want to tell you a little something, have you do me a favor. If you would subscribe to this channel, Meineke Math, on YouTube, that would be great, just because it kind of gives you notifications when I update something new. I feel like out of everything we have going on for my class, my online class right now, we got Khan Academy, we got notes printed on or posted on Teams, and we have these YouTube videos. I think the best thing you could do is watch these YouTube videos and maybe take notes in your spiral, okay? And then go on Teams. If there's some worksheets or practice questions, try them out. That would be good. You could try out practice questions on Khan, but I think that these videos are going to be the most helpful just because you can kind of hear me talk through them, okay? So please subscribe, want to become YouTube famous, get that money, Okay. Open up your spirals. We are on our last lesson. Whoa. Done lots of math this week. All right. Today's topic is on fractional exponents. Okay, fractional exponents. So we've been dealing with exponents of whole numbers, so raising something to the third power, second power, or whatever. Well, we're actually going to be using exponents that are fractions today. Seems scary, but it's not, okay? But I do want you to know that there is kind of a second way to say this in the math world. I say fractional exponents, but it's the same thing as rational exponents. And I'm telling you that because just in case my notes aren't helpful to you, you can always Google search this phrase or YouTube search this phrase, and it should give you some good stuff, okay? But hopefully my notes are helpful. Okay, so here are just some ideas that we have learned over this past 3 weeks of the closure, okay? Something I guess we haven't learned this yet, but I'm teaching you this today. A big idea is that radicals, and remember radicals are the little square root symbols, okay? Radicals, or let's call them roots. And you can do a little square root if you wanted to remind yourself what it looks like. But a big idea is that radicals or roots actually undo or cancel out exponents. So that's a pretty big idea. So I'm going to prove that to you right here, right now. Okay, I'm going to prove that radicals or roots actually undo exponents. So let's kind of write down a phrase. So if I were to ask you to take the square root of 4 squared. So put that in quotes. The square root of 4 squared. Now, what the heck does that look like? Square root of 4 squared. Well, square root is this thing. Now, do I put a number up here? Well, I can. The only number I would put up there is a 2 since it's a square root. But remember, if it doesn't have a number, we know it's a square root. It's just implied. So the square root of 4 squared. So this is going to be inside our radical. It's called the radicand. How do I write 4 squared? Well, that's 4 to the second power. Okay, so the square root of 4 squared. So if I had that on a worksheet or you saw it on a test, you would need to simplify it. So I'm hoping you would go, okay, well, 4 squared is 16, so that's really just the square root of 16. And then what is the square root of 16? Well, it's 4. Now notice that taking the square root of that something squared got you back to that something, right? Taking the square root of 4 squared got you back to 4. So it's like this radical canceled out the 2 and left you with 4. Let's see another example. The square root of 7 squared. Okay, and if I'm going too fast, pause the video, catch up whenever it's needed, okay? Square root of 7 squared. Well, let's go ahead and write it. So I'm taking the square root of something, and that something is 7 squared. So that's 7 to the 2nd power. So if I was simplifying this, I would simplify the radicand first, the number inside. 4 squared is 49. So I'm trying to find the square root of 49. 49 is a perfect square number. What's the square root of 49? 7. Okay, so I'm hoping you're seeing what I'm trying to teach you here is that this square root, actually undoes or cancels out the exponent of 2. So this radical cancels out the 2, and I'm left with 7 as my final answer. Okay, so the big idea is that if you take a square root of something, I'm going to use x, of something squared, what are you left with? You're left with x. Square roots cancel out exponents of 2. I'm left with the base of x. Okay, so that's a big idea, something you need to know. But let's talk about cube roots now. So let's do just a few more examples like this. Let's take the cube root of 3 cubed. The cube root of 3 cubed. Okay, let's get practice writing that. So I'm taking a cube root. So I do this fancy radical symbol, but since it's a cube root, I have to put what number there? I have to put a little baby 3. It's a cube root. And I'm taking the cube root of 3 cubed. So 3 cubed is what goes on the inside here. 3 to the 3rd power. Holy cow, that's a lot of 3's. So if I'm simplifying this, my first little step in simplifying is to probably simplify the radicand, that number inside the radical. 3 cubed is 3 times 3 times 3. So 3 times 3 is 9. 9 times 3, 27. Okay, and then the square root, the cube root of 27 is in fact 3, because 3 cubed is 27. So what we notice is that a cube root undoes this exponent of 3. It cancels out that exponent of 3. Let's try one more. The cube root of 5 cubed. Cube root of 5 cubed. Go ahead, set up what that looks like. Should be having this. Now I'm hoping you just know the answer is 5, because a cube root is going to cancel out something cubed, okay? If you needed to do that in-between step to kind of convince yourself, you would go, okay, 5 cubed, 5 times 5 times 5, that is 125. Cube root of 125 is 5, because 5 cubed is 125, okay? All right, and let's make sure this is making sense to you. So let's go general here. Let's use some variables. If I took the cube root of x cubed, write down what that equals. Cube root of x cubed. And that's totally just x. Okay. Now, could we go beyond this? Yeah, we could go even more general. So let's use like so many variables. Let's say we are taking the nth root. That's a variable. N means any number you want, any root that you want. let's take the nth root of x raised to the nth power. So these numbers are the same here. They're both n. Well, what would be the nth root of x to the nth power? Just be x. So that's a pretty big idea right there. Okay. Now, I hope you're like asking yourself, how does this kind of connect back to what we were doing with, you know, product rules and zero exponents and power rule? I hope you're asking that because this is where everything kind of comes together. Okay, this is where I kind of tie in our lessons with radicals to our laws of exponents. All right, so I'm going to call this little section in our notes. You're going to kind of ask yourself a question, and you're not going to know the answer yet. I want you to ask yourself, how else can an exponent be undone? And if you don't like this word, like undo, undone, you could say cancel out. Radicals cancel out exponents. How else can an exponent be canceled out? That's what I'm trying to get at here. Okay? Okay, so hopefully you don't get too lost in what we're about to do. This is higher level thinking here. I want to go back to this whole thing of square root of 4 squared. So the square root of 4 squared ends up being 4 because the square root cancels out something being squared. Let's go back to this 4 squared. Okay, just write down 4 squared on your paper. One way I could undo the exponent is to use a square root. I could take the square root of this and I would end up with 4. But guess what? There is another way to do it. I can actually take this radical, I can take this exponent and I can raise it to a certain power. I can raise it to some power. Now I'm going to leave that a mystery right now. But I can raise that to a certain power and have it actually end up being an answer of 4. Okay? So just like here, a square root of 4 squared canceled out when we were left with 4. There's another way you could cancel out this exponent of 2 and just have your final answer of 4. Okay, so we're going to work kind of backwards here. How else could I get 4 as an answer? Well, I could take 4 and I could raise it to the power of what? What would be up there, a 0 or a 1? It would be a 1. Okay, so I want you to kind of think to yourself, what number would go up here? What could I raise this to in order for this to all become 4 to the first power? And keep in mind, if I put a little exponent up here, I'd be using the power rule. Power rule says that you multiply the exponents. So 2 times something is 1. Is that number going to be a 0? No, 2 times 0 isn't 1. 2 times 1 isn't 1. It's going to be a fraction. What fraction is it? It's half. Yeah, so 2 times half is 2 halves, and 2 halves is 1 whole, so that's 4 to the first power. So another way to undo exponents, one way is to take the square root, and that clears out the exponent. But you could also raise it to the power of half in this case. So if your exponent is 2, you could raise that to a power of half, and that would cancel to a 1. 4 to the first power is just itself. Okay, this is kind of a weird concept, so we're going to practice some more. Let's go to 7 squared. So if I said, hey, I want you to cancel out that exponent of 2. Well, you can't just scratch it out. I want you to do it mathematically. So let's look up here. One way is we could take the square root of 7 squared, and that gets us back to 7. Okay, it cancels or undoes the exponent. But another thing I could do is I could raise it to a certain power and have it actually end up equaling 7. Okay, so I'm basically trying to raise this to something where if I multiply these two numbers, I end up with 7 to the first power. So what fraction, what number would have to go up there? It'd be half again. Because 2 times half is 2 halves. So it'd be 7 to the 2 halves power. Well, 2 halves, 2 over 2 is just 1. 7 to the first power, 7. So that's another way we can kind of undo that exponent. Okay, let's go on to some things that were cubed. 3 cubed. One way to clear out the exponent of 3 is to take the cube root of it. That'll clear it out and you're left with the base of 3. Okay, but another way is we could raise this to a certain exponent and have it end up equaling the base of 3. Okay, now the whole idea is I want this to actually end up being 3 to the first power. So let's be careful here. What fraction is going to come up here? 3 times something is 1. If you're thinking half, because that's what we've been doing, it's not a bad guess, it's just not the right answer. If you put a half right there, 3 times half is 3 halves, 3 over 2. 3 over 2 is not 1, okay? 3 over 3 is 1, which means we would want that fraction to be 1/3. 3 times 1/3 is 3/3. 3/3 is the same as 1. 3 to the first power is 3. Okay, let's do another one. 5 cubed. What are you going to raise that to? Oops, not 5. Excuse me. 5. 5 cubed. What are you going to raise that entire thing to in order for it to equal 5? Hoping you said 1/3. So I multiply the exponents here, multiply your powers. That's the power rule. 3 times 1/3 is 3/3. 3/3 is just 1. 5 to the first power is 5. Okay, let's go crazy here. Let's take 10 to the 8th power. I want you to do something to that exponent, and I want you to make it equal 10 at the end. Now, one way you could do this is to actually take a root of it. What root would you have to take? You have to take the 8th root. So the 8th root of 10 to the 8th is 10. But I want you to actually raise it to a fractional exponent. Think about what fraction that would be. If you had half up here, 8 times half is 4, and 10 to the 4th is not 10. So the only option here is to raise it to the 1/8 power. 8 times 1/8 is 8/8, which is 1. 10 to the first is 10. Okay? So here is the big idea. So hopefully you have some room. We're going to write this nice and big. So what I need you to know at this point is the square root of x. Go ahead and write that down. The square root of x is exactly the same thing as x raised to the 1/2 power. Those two things are equivalent to each other. What that means is if I give you a number and it's raised to a fractional exponent of 1/2, you go, oh, that's just the square root of it. And you take the square root of that number, okay? And then to go along with this, this is very similar, I'm just using a different fraction. The cube root, so put a little 3 there. The cube root of x is the same thing as x raised to what power? What power is going to go there? A 3? No. A 1/3. Okay? So that's another big idea. All right? Now let's get a little bit more practice doing some conversion here because that's a huge idea. So that's going to be our next little chunk in the notes. We're going to say converting. Okay, we're going to convert. I'm going to start off with n to the 1/2 power. Now convert means change. So we're going to change from exponential form to radical form, or radical form to exponential form, okay? So I want you to be good with both ways. So n to the 1/2 power, I see this exponent as a fraction, and I think, oh my God, what? And then I calm down and I go, oh, fractional exponents, that's kind of like a root. It's the same thing as a root. So I know that this is gonna be, it's gonna have a radical involved. So go ahead and draw your radical. Now, the number underneath the radical, which is called the radicand, is gonna be this base right here, this n. So you're gonna transfer that over. Now, there might be an exponent on the inside. There probably is gonna be an exponent out here though, and that's a root, not an exponent. But what is the root gonna be? Is it gonna be a cube root, a fifth root, a root of 2? And the answer is it's gonna be a square root, okay? And that's because your denominator is a 2. Now you can put a 2 there, but remember you don't really need it. If you have a root and nothing is right there in the index, then you know it's a square root. So that would be your final answer. N to the half root, n to the power of half is the same thing as the square root of n. Okay, let's do another one. N to the 1/3 power. Go ahead and write that in radical form. So what would your root be? Square root? Cube root. Definitely a cube root. Okay. Now, I hope you're kind of asking like, okay, so the number down here, the denominator is your root. Cool. Where did this 1 go, Meineke? I hope you're asking yourself that. And that little 1, that numerator of the fraction, really does go right here. It's the exponent of the radicand. But the reason why I didn't write it up here is because what's n to the first power? It's just n. So it's just not necessary. Not always necessary. So let's kick it up a notch here. Let's take n and let's raise it to the 4/5 power. Now this is a little bit beyond what you need for this chapter. You definitely need to know this stuff for this chapter, but let's just practice rewriting this. So I see a fractional exponent and I think, oh, that's gonna be some sort of root. I'm gonna put the n in the inside. Now, what root is that? Is it a 4th root or a 5th root? And if you're questioning, look at what we did here. This was a cube root because the bottom number was 3. There's a secret 2 there because the bottom number was 2. So this is definitely going to be a 5th root. And then where do we put this 4? Well, it's the exponent on the radicand. It's exponent on n. Okay, and then I'm going to write this one down. Pause the video, try it out. Okay, n to the 2/3 power. It is going to be a cube root because the denominator is a 3 and the power of 2 goes on the n in the radicand. Okay, so that's just some converting. Now you should probably tell yourself kind of the main idea of what numbers go where, which are the root, which are the exponents. So let's just write that in your notes real quick. The denominator, and if you don't like that word, you can write bottom number, okay, but you should be comfortable with denominator. The denominator of the fractional exponent okay, so the bottom number of this guy is the, and I'm going to use fancy vocab here, it's the index. And how I think of it is it's the root. Okay, it's the root of the radical. And the numerator of the fractional exponent is the exponent of the radicand. Another fancy word there, radicand. I'll put the normal language in here. Radicand is whatever's underneath the radical. Okay, so I'm going to say number under the radical. Whew. Pause and catch up if you need to. So denominator is the root, numerator is the exponent on the inside. Okay, and now we got to do some practice questions, and that'll be it. Okay, practice questions. Here we go. We got 16 raised to the power of 1/2. 16 to the 1/2 power. I see a fractional exponent. I go, oh my God, that's crazy. And I think, no, it's not. It's just a root. Is it a cube root, square root? What do we got going here? Denominator's 2, so it's definitely a square root. You could put a 2 here if you wanted to, but it's not needed. And then the square root of 16 is 4. Final answer. Okay. Number 2, 100 raised to the 1/2 power. Pause the video, try it out. So something raised to the 1/2 power is the same thing as taking the square root of it. So we just have to take the square root of 100, which is 10. Final answer. Okay. Next, let's shake things up a bit. We got 81 raised to the 1/2 power. We're not done though. Plus 8 raised to the 1/3 power. Well, fractional exponents, I know we're going to have roots going on here. We just got to be careful about how we set them up. So if I have a fraction of 1/2, that's definitely going to be a square root. You can put the 2 or not put the 2. I'm going to put it in this one just for fun, okay? And that's the square root of 81. We could put it to the first power, but we don't need to. This one, is it going to be a square root? A 7th root? What's it going to be? It's going to be a cube root. That's because the denominator is 3. So we're taking the cube root of 8. Okay, let's simplify our radicals. Square root of 81 is 9. Cube root of 8 is 2. 9 plus 2, 11. Okay, number 4. And this is where we tie everything together here, guys. We're going to have 25 times x to the 4th, but we're not done. We're going to take all of that, so group it up. We're going to take all of that and raise it to a power. So this is going to be power rule. We're going to raise it to the 1/2 power. Okay, power rule, and if you want to kind of write to yourself off to the side, power rule. Reason I say power rule is I see some stuff raised to an outer exponent, so that outer exponent kind of gets distributed to every power on the inside. And remember, 25 has a secret power of 1, okay? So this is going to be 25 to the 1/2 power, but that half also gets distributed to the 4. So I'm going to take 4 times half. 4 times 1/2 is 2. All right. Now, 25 to the 1/2 power. Maybe I can simplify that further. So how I'm going to check is I'm going to remind myself that something to the 1/2 power is the same thing as taking the square root of it. So that's the same thing as square root of 25. And then x squared, I can't really do much there. It's just x squared. But what is square root of 25? It's 5. So my final answer is 5 times x squared. Let's do 2 more examples and then we'll call it a day. All right, so we're going to have -8 times x to the 0 power times y to the 12th. and we're going to group all of that together and raise it to the 1/3 power. Ooh, this is another power rule, okay? So that 1/3, that outer exponent, kind of gets distributed to each power on the inside, including that -8. Now that -8, you got to protect it in parentheses, okay? Because notice how it's in the big set of parentheses. So when I bring just that chunk down, I'm going to protect the negative in the base, raise it to the 1/3 power. Let's go to the x. 0 times 1/3 is still just 0. Let's go to the y. 12 times 1/3. You can use your calculator or just know that 12 times 1/3 is 12/3. 12 divided by 3, 4. Okay. We're not done though. I can actually do some simplification here. Okay. So raising something to the 1/3 power is the same thing as taking what type of root? Cube root. So we're going to take the cube root of -8. Now, x to the power of 0, anything to the power of 0 is just 1. Y to the 4th is good to go. Okay. Cube root of -8. Make me proud. Think, what's the cube root of -8? Something cubed is -8. And it's not 2. It's -2. The 1, anything times 1 is itself, and then I just bring down the y to the 4th. Final answer, -2y to the 4th. Okay, last one. Now this is gonna look different. This is one that was on your test that I had planned to give you like last week or something. Got the square root of x times the 4th root, so put a little baby 4 there, the 4th root of x cubed. Whoa, what's happening here? Now you might be looking at this going, what am I doing here? Do I multiply the x and the x and make it x to the 4th? Well, no, you can't actually multiply the radicands because they don't have the same root. Well, is there anything else we can do? Well, maybe we change it from radical form to exponential form. So it'd be like what we did here, but the opposite way. So I take it in radical form. Let's put it in exponential form. So square root of x is the same thing as the square root, square root of x is the same thing as x raised to what power? 1/2 power. Okay. Now go ahead and try and rearrange this into exponential form. It's definitely going to be fractional. Numerator is the number on the inside. Denominator is the root, which is on the outside. So this is equivalent to x to the 3/4 power. Okay? Now let's go through our laws of exponents. Product rule. Remember product rule? Product is when you're multiplying. Product rule, we could apply product rule as long as we have the correct requirements. Product rule says if bases are the same, then you add the exponents. So are the bases the same? Yeah, they both have a base of x. So I can just add the exponents. So off to the side, maybe write to yourself product rule. And what we're going to do is we're going to actually add 1/2 plus 3/4. Okay, bases are the same. I just add the exponents. 1/2 plus 3/4. Now, if you want to grab your calculator and put this in, that's fine, but I'm just going to go old school here. I need common denominators, so 1/2 is the same thing as 2/4. 2/4 plus 3/4 is 5/4. So this, when multiplied through, is equivalent to x raised to the 5/4 power. And that could be one way to write your final answer. This final answer is written in exponential form. Go ahead and write that off to the side. Now I'm saying that because Khan Academy or a test, it might have specific directions and say write your answer in exponential form. And that means raise the base to an exponent. but it might actually ask you to write your final answer in radical form. So what that means is we go from exponential back to radical, back to looking like this. Okay, so let's get a radical in there. I know x is going to be down here. We just got to locate where the 5 and the 4 are going to go. Okay, the root, the number out here, the root is your denominator, so it'd be the 4th root. And then that 5 is the exponent on the inside. So this is another way you could write your final answer, the 4th root of x to the 5th. Okay, that wraps up all of our exponent stuff. And next week, guys, is spring break for us. So what that means is I technically don't have to post any new lessons or videos. I kind of get a break. So I know some of you have been breaking for 3 weeks. So my hope is that you get caught up, okay? I still want you learning. I'm not going to overstress you too much. Hopefully I'm not right now. But I still want you learning. I want your brains to be active. I don't want them to just become mush. So have a great weekend, and thanks for watching. See ya.